Lesson 15.9 is average rate of change from a graph. It's going to want you to draw a line. So the function y equals f of x is graphed below. Plot a line segment connecting the points on f where x is -3 and x is 2. Then we're going to use that line segment to determine the average rate of change of the function on the interval where x's are between -3 and 2. So taking something that's curved, and that's a big chunk of what calculus is finding slopes or average rate of changes of a curved function. And how they do that is by limiting it between two x values. So we simply want to figure out on this function, here's x is -3, here's the point on the graph where x is -3, finding 2 and doing the same thing, and then not worrying about the curve, but simply taking something that's straight, and on the computer you'll just click and click and it'll make a straight line, and really finding slope of this line I just made. That's what average rate of change is. Anytime you're averaging something, it's not always exact, but it's a good approximation. And so if we remember slope of a line is y2 minus y1 over x2 minus x1. They also sometimes will say change in y, and this delta symbol, this is a triangle, but they call it delta y over delta x. That means change in y and change in x. So you just find slope, nothing new. What I would do is look at this picture and pick out ordered pairs. So when x was -3, this point had a y value, it must be -2 because it's counting by 2's. And when x was 2, y must have been -10. So from there I'm just doing slope formula. I'm doing -10 minus -2, which would turn into +2, over 2 minus -3, or 2 plus 3. And that would be -8 over 5. That's my slope. But they're going to break this up and say, what is the change in y's? What are we going down? We're going down 8, and then we're going right 5. And then the average rate of change as a fraction is that change in y over change in x. So you could also just look at the picture and count. Just be aware that they don't always count by ones.